Good morning students, this is Usha from G.K.Jain High Secondary School. Today we are going to learn about measurement in 11th standard physics. In this we are going to learn about the different system of units. Let us move on to the topic. Measurement. Comparison of any physical quantity with its standard unit is called measurement. Measurement is the basic of all scientific studies and experimentation. It plays an important role in our daily life. So now we are going to see the definition of physical quantity. Quantity that can be measured and in terms of which laws of physics are described are called physical quantities. Example, length, mass, time, etc. There are two types of physical quantities. They are fundamental quantities and derived quantities. First, we are going to see the fundamental quantities. Fundamental or base quantities are quantities which cannot be expressed in terms of any other physical quantities. Example, length, mass, time, etc. And second one is derived quantities. Quantities that can be expressed in terms of fundamental quantities are called derived quantities. Example, area, volume, velocity, force, etc. Definition of unit and its type. The process of measuring is basically a process of comparison. An arbitrarily chosen standard of measurement of a quantity which is accepted internationally is called unit of the physical quantity. The unit in which the fundamental quantities are measured are called fundamental or base unit, and the unit of measurement of all other physical quantities, which can be obtained by a suitable multiplication or division of powers of fundamental units, are called derived units. Different types of measurement system. A complete set of unit which is used to measure all kind of fundamental and derived quantity are called system of units. Here they have used common system of units in mechanics. They are, the first one is FPS or British system. It is the British engineering system of units which uses foot, pound and second as the three basic units of measuring length, mass and time respectively. The second one is CGS system. The CGS system is the Gaussian system which uses centimeter, gram and seconds as the three basic units for measuring length, mass and time. Okay. And the third one is MKS system. It is based on meter, kilogram and second as the three basic units for measuring length, mass and time. Next we are going to see SI system. The SI with the standard symbols, unit and abbreviations were developed and recommended by the General Conference on Weights and Measurements in 1971 for international usage in scientific, technical, industrial and commercial work. The advantages of the SI system are: the first one, this system make use of only one unit for one physical quantity, which means a rational unit system. Next, it is called coherent unit system. In this system, all the derived unit can be easily obtained from basic and supplementary units, which means it is a coherent system of units. It is a metric system, which means that multiples or submultiples can be expressed as power of 10. Next, we are going to see the SI base quantity and its units. So, as the base quantities are length, mass, time, electrical current, temperature, amount of substance and luminous intensity. They are called as base quantities. Now we will see the unit and the symbol. For length, the unit is meter and the symbol is m. Mass, it represents kilogram and kg. Time, seconds, s. Electric current and the unit is ampere and the symbol is A. Temperature Kelvin K. Amount of substance mole, it is given as a symbol of MOL. Luminous intensity candela and the symbol is CD. Now we will define 1 meter. 1 meter is the length of the path traveled by the light in vacuum in 1 divided by 299,792,458 of a second. Okay, next we'll see 1 kilogram, that is for mass. 1 kilogram is the mass of the prototype cylinder of platinum iridium alloy preserved at the International Bureau of Weight and Measures at Sevres and near Paris. Next is 1 second. 1 second is the duration of 9,192,632,770 period of radiation corresponding to the transition between the two hyperfine level of the ground state of cesium-133 atom. Then for electric current, 1 ampere is the constant current which when maintained in each of the two straight parallel conductors of infinite length and negligible cross section held 1 meter apart in vacuum shall produce a force per unit length of 2 into 10 power minus 7 Newton per meter between them. Then 1 Kelvin is the fraction of 1 by 273.16 of the thermodynamic temperature of the triple point of the water. 1 mole is the amount of the substance which contains as many elementary entities as there are atoms in 0.012 kg of pure carbon 12. 1 candela is the luminous intensity in a given direction of a source that emit monochromatic radiation of frequency 5.4 into 10 power 14 Hz and has a radiant intensity of 1 by 683 watt per steradian in that direction. The next one is, you are going to see the derived quantities and their units. So here they are given the physical quantities, expression and unit. If the physical quantity is going to be plane angle, then the expression is r by radius, which is given as rad, R-A-D. Solid angle, surface area by radius square, that is square of the radius, which is given as SR. Area, as you all know, it is length into breadth. It is measured in meters, so we'll get it as meter square. And for the volume, area into height, so meter square into meter, you'll get it as meter cube. Then we comes to the velocity. The velocity formula is displacement by time and the unit is meter per second because the displacement is measured in meter and time in seconds, so we'll get meter per second. Acceleration, velocity by time, so meter per second square. Angular velocity is nothing but angular displacement by time, radian per second. Angular acceleration, angular velocity by time, so radian per second square. Density, the formula is mass by volume. So mass we'll measure in kilogram and volume is meter cube. So we'll write kg m power minus 3. Linear momentum is mass into velocity. So the mass is kg and velocity unit is meter per second. So substituting a linear momentum will be kilogram meter per second. Moment of inertia. The formula is mass into square of the distance. So kilogram meter square. Force, mass into acceleration. So unit is Newton, or it also can have kilogram m meter per second square. Then we comes to the pressure. The formula is force by area. So the unit is Pascal or Newton per meter square. Energy or work. The formula is force into distance and the unit is joule or Newton meter. Power is work by time, so joule per second or watt. Then we can learn about the impulse, right? Force into time, so Newton second. Surface tension, force by length, so you will get it as Newton per meter. Moment of force, torque, that is force into distance, is Newton meter. Electrical charge, current into time, so current is ampere second or you will have it as coulomb. Current density, current by area, that is ampere per meter square. Magnetic induction, force by current into length, so Newton per ampere per meter or Tesla. Force constant, force per displacement, so Newton per meter. Planck's constant, energy of photon divided by frequency, joule second. Specific joule second. Next, specific heat, heat energy by mass into temperature, so joule per kg per Kelvin. The last one is Boltzmann constant K, energy by temperature, joule per Kelvin. Next is radian. 1 radian is the angle subtended at the center of a circle by an arc equal in length to the radius of the circle. The steradian is the solid angle subtended at the center of a sphere by that surface of the sphere which is equal in area to the square of the radius of the sphere. So here you can note it out. Pi radian is equal to 180 degree. So if I want to calculate 1 radian, what I should do? 180 divided by pi, which is equal to 57.27 degree. So 1 degree is equal to 60 minutes of arc and 1 minute is equal to 60 seconds of arc. So what is the relation between radian, degree and minutes? So 1 degree is equal to pi divided by 180 radian. So we'll get the answer as 1.745 into 10 power minus 2 radian. So then we have 1 minute of arc is equal to 1 degree divided by 60. So 1.745 into 10 power minus 2 divided by 60. The answer is 2.91 into 10 power minus 4 radian. So 1 second of arc is equal to 1 degree divided by 3600. Substituting the value, we'll get it as 4.85 into 10 power minus 6 radians. Thank you. Yes students, you all have learned about the different system of units. We will meet you in the next video. Thank you.